Hello and welcome everyone to our solution to the Data Mining Cup 2020. We are a team of 3 persons, Uttam Kumar, Florian Huber and Morris Atrops. We took part in this event as a part of our Big Data Analysis Lab course supervised by Professor Dr. Emmanuel Müller. To move with our solution, we started with the data pre-processing part. Now it's not very natural as a machine learning approach, but we started with our solutions from looking data first in the simulation period and then going for the training period. In the simulation period, we found that there were around 1843 items that were on promotions, with promotion frequencies in range 1 to 3 in the bi-weekly sales. Drawing similar correlations in the training period, we made a customized functions which can detect promotions and have around similar promotion frequencies. So as a result of the function, we can see the graph along sides. The red line curve shows the number of items in promotions on simulation, and then the black curve shows the number of items in promotions during the training. Moving to the next visualizations part, actually we had various visualizations, but adhering to the time constraints, we will look only on few of them. We tried to find correlations in the number of items being sold and their sales prices. For some of the items, as the sales price dropped, the number of units being sold increased. But however, this was not true for all of the cases, all of the items. Apart from this, most of the items had peaky sales that we correlated to promotions. So drawing insights from our visualization, we tried to make the best uses of the features. So we split the data set in 4 parts. The first section being the items on promotions with varying sales price. The second section being of the items in promotions with a constant sale price. And then the items that were not in promotions and having varying sales price. And as our 4th section, it was the number of items, the items which were not on promotions and having a constant sale price. So next we move to Morris.
Yes, the feature engineering and feature selection part of our project. So in total, we used 68 features in our model. The top 10 features with respect to their Gini importance you see in the graph on the right. With respect to our feature engineering, our most important handcrafted features were the bi-weekly frequency of promotions. So on how many days in the last 2 weeks was an item promoted. We had the difference of sale price and recommended sales price, indicating a discount for a certain item. And the flag is first prom, indicating if it was the first promotion for an item until the certain day in training period. One last remark to this is the feature importances actually differ quite a bit based on which data set you look at from the 4 that Uttam already mentioned before. Now we move on to the model section.
Using all this information, we actually managed to train 5 models. We train 1 for each of the 4 data selections we have seen previously, under the assumption that items in those similar categories will behave similar. And we have 1 extreme random forest trained on the whole data, under the assumption that there may be still some correlation between those groups we defined. Obviously, we trained all the models using grid search, and in the end, we used an ensemble method to integrate all of 5 models into 1 based on the item categories and based on the monetary value we could calculate with the given evaluation function. So yeah, this is the last slide now. So thank you for your attention. As we are a team of 3 students, please make sure to also check out our other solution on the DMC website, University Bonn 1. And if you have any further question, please reach out to us per mail, as you can see on the screen.